So here we're going to do some computer vision. I was very pleased to see this available in one of those books. There's this online database called the Fashion MNIST database just for machine learners to practice on, and they got this from some clothing store, I guess. So you have 28 by 28 grayscale images, and this is supervised learning. We're going to learn from labeled data. So there's a bunch of pictures of clothing, and they're sorted into these categories like t-shirts and coat and sandal and sneaker and things like that. And original data set has a bunch of, to each image is 784 values, 28 by 28 pixels, and each value is from 0 to 255. That's the brightness, so that's the input data. So you're going to have a complex neural network with a whole bunch of input neurons, one for each pixel, then some hidden layers, and then some output neurons that will sort it into categories. So here's the plan in more detail. The input image is 28 by 28 grayscale. All the pixels go into neurons here. Then those neurons go to the hidden neurons. Each one, the hidden neurons combine the input from all that and go to the output neurons, and the output is going to be the probability that it is a coat, a sneaker, or a bag, or what else it might be. And so here's the code that does that. Again, it is very simple. So I'll put it in Colab. Make a new notebook. All right, and so you see here, it's got the input layer is 28 by 28. That's all the pixels. The hidden layer is 128 neurons, and the output layer is 10 neurons, where it sorts it into those 10 categories. And the training image is here, and the data comes in. It loads the data from this data set that's already included in the Google Colab environment, and it sorts it into training and test groups. This is typically what you do. You take some number like 80% of the data and train the model on that, and you take 20% of the data and test the model on that to see how well it did. And that's what's going to happen here. It's going to fit the model with 5 epochs of training, so starting and 5 attempts to improve it, and then it's going to test it against the test label. And this is a much more complicated situation than the previous ones we've done, much larger amounts of input data. So we only do 5 epochs of training. Okay, so there it is, downloading the data. And here it is running the epochs, 1 of 5, and see each epoch is now taking something like 12 seconds. Whereas the previous ones were doing many epochs per second for those very simple models. So it'll take about a minute or a minute and a half to do the training. And notice the accuracy is going up, the loss is going down, so it was 82%, but it went up to 89% accuracy. All right, and so let's look at the results. Here we can print a chart showing how accurate it is. Since it's only 89% successful, that means there should be a considerable number of errors we can find. And I don't know why it's still running. Oh, it's doing the evaluation on test images. Okay, that's right. So it's going to, this was the fitting. It's doing the evaluate. I'll let it finish, and that'll show one point worth noting here. There. So here it is evaluating on a test image, and the answer is 87%. So it's 89% accurate on the training image, but only 87% on the test images, and that's what you'd expect, right? It's trained on those images. And it is possible, by the way, to overtrain models where it fits not only the real trend of the test data, but the coincidental idiosyncrasies in the test data. So even though it has a lower error on the test data, it actually, on the training data, it actually has more errors on the test data because the stuff it's learning is not really representative of the population as a whole. Anyway, let's go down here and look at the results for the first 20 images. We should be able to find some mistakes in here. So what you're seeing here is the probability of various categorizations. So in the first number is the correct answer. So this is columns 0 through 9. The right answer is 9, and you see it says there's an 89% chance of 9 and smaller chances of the other one. So it got the first one right, the second one right. To find the errors, you'll want to find small numbers down here, like this 76 and 21. This was really a 7, but this is 1, 2, 3, 4, 5. It was misidentified as a 5, with only a 21% chance of being 7. So this one was a mistake. Now, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's number 11, I think, maybe. See, I don't know if you count it 0. I think you do count it 0. 5, 6, 7, 8, 9, 10, 11, 12, 13. Might be 13. I'm going to go with 13. 13 is one it got wrong. So we can view a couple of the pictures it got wrong. Down here, I'm going to start with this code and then modify it. I want to see 13 here. Image number 13 it got wrong. Image number 0 it got right. So we should be able to see an example of one it got right and one it got wrong here. So it got that right, but it got this wrong. And it couldn't tell if this was a 5 or a 7. And the categories 5 and 7 are a sandal or a sneaker. So I think probably a coat and a shirt. I think I must be off by one in my counting. I would think more likely the problem here is you can't tell whether it's a coat or a shirt. When I did it before, I had this one, which I couldn't tell whether this image was a sandal or a sneaker, which is reasonable. And this time it was this one, which you can't tell if that's a coat or a shirt, and I tend to agree. You can't really see much in that image. So it has the same kind of problem a human would have categorizing things. And you can see this live if you look at the videos of Teslas driving around. Teslas are using machine learning, just like this. And if they're going down a freeway and they see something like a homeless person pushing a shopping cart, you can see the Tesla think, is that a car? Is that a tree? Is that a dog? What could that be? Because it doesn't really look much like any of the things it expects to see, and it can't really figure out what it is and therefore what driving to do to get past it. So it's doing just this kind of work with just these kind of flaws. So anyway, if you train it more, it gets better, and you can find a flag here. So that's the next one to try. I see